It's time for another integral of the day, and we are trying to integrate 3 cos 2x plus 1 dx using trigonometric identities. So cos double angle, there are a few different things that might be useful with this. In general, we normally use either, so cos, sine, sine, so we normally use 2 cos squared x minus 1, so, you know, that one there, or 1 minus 2 sine squared x. So which of those might I want to introduce? Because the cos squared minus sine squared is very rarely the one that you want. Well, this one might work quite well. The reason for that is because you'd sub this in, yeah, with the cos double angle, and then you would have the minus 1 and the plus 1 working together. So I think we should try that one there. So let's do that. So if we substitute this part out, it's going to become what? It's going to become the integral, well, 3. When you've got numbers just in, numbers can just go out, okay? So I've got 3, 1 over, and we said we were going to try the 2 cos squared x. If I put this all in brackets, minus 1 instead of that one, plus 1. So perhaps that might be the way to do it. When I do that, these brackets aren't really doing anything, so I'm just going to cancel out those ones there, and I'm going to just sort of rewrite, I think. So I've got 3, 1, and then I've got 2 cos squared x, haven't I? And again, I could, you see that 2 there? I can just take that out and just do that. I am allowed to do that because, well, if you try it, you know, if you sort of multiply it like fractions, of course, it could just go there. So this doesn't seem that helpful. But what you've got to remember is that for trig, sometimes writing it in terms of those reciprocal functions like sec and cosec and so on can actually be quite useful. So what would this one be? If it's C, it's the one where the third letter is C, isn't it? So this is actually sec. So I could rewrite all of this instead as 3 over 2, the integral of, well, it's sec squared dx, isn't it? So sec squared, why is that a good thing? Well, sec squared, perhaps I know things about like where that expression comes from, for example. So sec squared comes from tan, doesn't it? Because tan differentiates to sec squared. So it's actually just 3 over 2 tan x plus c. So I suppose the thing to kind of be aware of for this is, yes, we sort of had some choices with cos double angle, which is a common feature. Yes, we sort of had some work about taking numbers out, but really not to be too afraid of sec, cosec, things like that when it comes to integration and differentiation, because there are results that we know about those, and they can actually mean that the question is much nicer than it first looks.